The first thing to start using AWS EKS is to deploy and set up prerequisites and the requirements. And during this part, I will teach you all the things need to be deployed before creating EKS clusters. If you didn't follow our social media, please follow our LinkedIn page, YouTube, and Telegram channel. During this part, I will teach you how to create an IAM user to be able to create clusters and deploy all the required resources, and that user will be act as our cluster owner. To be able to create AWS resources from our machine, we need to set up AWS CLI. But keep in mind, you can use AWS Cloud Shell, Terraform, Pulumi, and any other applications. After creating the user and set up the environment, we need to create a VPC to have an isolated network infrastructure within our AWS region to be able to deploy AWS instances, resources, and all the things. And after that, we need a couple of public and private subnets to create our Kubernetes worker nodes. In the case of public subnets, if you deploy any instances into public subnets to allow them to access to the internet, we need an internet gateway. And for the private subnets, when we want to allow them to access to the internet while no one from the internet or outside our network, our VPC, access to private instances, we need to set up a NAT. And in AWS, we need to create a NAT gateway to be able to provide a way to our private instances to be able to connect to the internet. And to allow our instances to route all the traffics to the internet when they are behind the NAT, we need to create an additional route table and use our NAT gateway as a default gateway in that row table and assign that row table to our subnets, and when any instance get deployed to that subnet, they can reach to the internet. And at the end, to be able to connect to our worker nodes through SSH, we need to create or import EC2 key pairs. So let's get started. First, we need to connect to our AWS account using our root user and go to IAM service. In IAM service, we need to create a user, an admin user, but as I already have the admin user, I just want to show you how to create a user. So I create a test user and attach administrator access policy to that user, but keep in mind, in production environment, you should grant access granularly into the users. And you should not assign something like administrator access or some other policies like that. Because in the production environment, the best practice is to provide at least privilege to everything. But because in this course we want to focus on EKS, I'm not willing to talk about IAM permission, policy, roles, user, and etc. And because of that, I just use the administrator access policy to be able to communicate with my AWS account. After creating a user, we need to go to that user under security credentials tab, we need to create an access key, a secret key. Now we have the credentials, and it's time to configure our AWS CLI tool. You can install AWS CLI directly on your machine, or just like I mentioned in this course, you can use Docker to run AWS CLI image. So we need to use this command. As I already have a container named AWS CLI, I use another name, AWS CLI test, to create a new container. And to get to this container, we can use this command to access the container shell. And now we are in. And it's time to configure AWS command line tool. To do that, we need to execute AWS configure. And it asks us to provide the credentials. So we need to copy the credentials. Note that your credentials should keep secret, and you have to put them in a safe place and do not expose it anywhere. The default region in our course is EU West 2 or London region. But because I already have everything in place and I don't want to delete the already created VPC, subnets, and etc., because this procedure changes our IDs, and I want to keep everything with the same ID during the course, I use another region, the Paris region. And the ID of this region is AUS3. So you can use AUS3, and by using another region, I can deploy all the things with the same value to show you how our environment looks like. The output format should be JSON, and now we are good to go. So the next step is to check with which user we can connect to AWS. And by running AWS STS get caller identity, we can get the current user. And as you can see, right now we logging in with the test user. So to check what we did during this step, we log in with our root user to the AWS console. We went to IAM service, and we created a new user called admin, and we assigned administrator access to that user. And after that, we created access key and secret key, the credentials. And then we went to our local machine, set up AWS command line tool with AWS configure command, and after that to check which user can access to our AWS, and we are connecting with which user, we use AWS STS get caller identity. The next step is to set up the environment. Inside our environment, we need at least one VPC. VPC is an AWS service, help us to create an isolated network infrastructure. And we need an isolated network infrastructure to be able to create instances and any other AWS services. So I can use this command to create VPC, and now we have the VPC ID. The next step is to get the information of our VPC. We need the VPC ID to enable DNS hostname features. We need to enable this feature because when we want to deploy Kubernetes worker nodes, they want to join the control plane using DNS hostnames. And we have to enable this feature. So I have to copy this command and change the VPC ID with the new created one. This is our VPC ID. I can use this one and enable DNS hostnames feature. And after that, it's time to create public subnets. We can get the availability zones in the current region using this command. And as you can see, in Paris region, we have 3 availability zones. You can see the information. We need this information in the next step. And we need to create our public subnets. So I have to change the VPC IDs as well as changing the availability zone. We have 3 availability zones, so we need to create 3 subnets within every availability zone. Okay, the first one is ready. We need to create the second one. The second one is ready. And the last one, this is the last one. Now, if we check our VPC, you can see we have the VPC. This is the CIDR block of the VPC. And right now we have 3 public subnets. And this is our CIDR blocks. The next thing is to enable public IP mapping feature to when we deploy a new instance into any of the subnets. AWS provides a public IP automatically to that instance. To do that, we need to copy these commands, change the information. This is the first one, and this is the subnet ID. I need the subnet ID here. The second one. And third one. That's it. And now we can execute these commands. Okay, all set. The next step is to create an internet gateway to allow all the instances within public subnets to be able to connect to the internet. To do that, we need to create internet gateway, and after that we have to attach that internet gateway to our VPC. So this is our VPC. And this is the internet gateway. And now we can execute this command to attach internet gateway. Okay, it's done. The next thing is to find the default route table created by our VPC. This is the main one. And we need the information. To get the information, you can run this command and you can find the route table ID here. And now we need to assign the internet gateway to our route table. So we have to change this one to this, and the internet gateway ID. This is the internet gateway ID here. And now we can create a new route. It's done. Now, if we get to that route table, you can see everything inside our VPC network goes through VPC, and the VPC manage the communication. But everything outside the decider block should goes to our internet gateway. And by adding this route, all the instances within our public subnets can access to the internet. So far, we deploy all the things required to deploy worker nodes, Kubernetes worker nodes, if we want to use public subnets. But if we want to use private subnets, we should follow these steps. So again, we need to create private subnets. This is our private subnets. We need to change the VPC ID again. VPC ID here, VPC ID here, and VPC ID here. Change the availability zone. And now we can run the first command to create private zone. Second one. And the third one. And now, if we check our subnets, you can see right now we have 6 subnets. 10.0.1.0 is our public subnet. 11 is a private one. 2 is a public. 12 is a private one. 3 is our public subnet, and 13 is our private one. Now, the next step is to create a new route table to assign to those subnets. The VPC ID should be changed. And if you check, we have a new route table. The next step is to associate that route table to our private subnets. To do that, we need the route table ID. We can find it here. This is the route table ID. We can update it here, here, and here. and we need subnet IDs. This is our subnet ID. The second one and the first one. Is done and done. Okay. The next step is to create a NAT gateway. To be able to create a NAT gateway, we need to create an elastic IP address first. To assign that elastic IP to our NAT gateway to be able to create it. To do that, we need to allocate a new address with this command, and it provides us a public IP address. And after that, we need to create NAT gateway. This is the elastic IP address. And we need a public subnet. Why we need a public subnet? It's because the NAT gateway should be deployed to a public subnet. In our public subnets, when some resource or some instance wants to connect to the internet, they have an internet gateway. And they use the internet gateway to access the internet. And they already have their own public IP address, and they can use internet gateway to connect anything on the internet. But in the case of NAT gateway, we need to assign a public address, a public IP address to our NAT gateway, and put that NAT gateway to a public subnet to allow that NAT gateway instance to be able to connect to the internet. And when an instance from our private subnets tries to communicate and access to the internet, they connect to the and send their traffic and packets to the NAT gateway, to the public subnet, and from the public subnet, the NAT gateway sends to sends the traffic to the internet. So we can use our first subnet, the public one, the first public subnet, to create a NAT gateway inside that subnet. Okay, now if we check elastic IPs, you can see the elastic IP is available. If you check the NAT gateway, you can see it's creating. It needs some time, and it takes about 2 or 3 minutes to be ready. In the meantime, I want to show you the diagram of what we did during these steps. So we have our AWS cloud, our account. Inside the AWS cloud, we get to one region, for example, London region. And within that region, we created a VPC with the big cider block. And in each availability zone, in that region, we created a couple of subnets. One public subnet and one private subnet. Public subnets can connect to the internet through the internet gateway, and they use the main and public route table. So everything gets deployed to the public subnet, can access to the internet because they have their own public IP address and they can get access to the internet. When we deploy something into our private subnets using the private route table, and when they want to get access to the internet, they send the traffic into their default gateway, and their default gateway right now is a NAT gateway, and the NAT gateway changes the source of that packet. It changes the source IP address to that elastic IP, and then it sends it to the internet gateway and can access to anything outside our cluster, our AWS network, our VPC, to the internet. This is the diagram of what we want to achieve. And please keep in mind, AWS charge your account for creating NAT gateway and elastic IP. So after testing the environment and implementing all the things, you have to delete the NAT gateway and elastic IP. And in the next step, in the next articles, when we want to use NAT gateway and elastic IP to be able to deploy private worker nodes, you can create it again. Now, if we check, yes, the NAT gateway is available and it's done. And then is the to complete our last step. And now it's time to create a key pair or import our key pair into the AWS to be able to connect to worker nodes, to the instances, through SSH. To do that, we can use this command to create a new key pair, and when you check, we have the private key here. And by using this private key, we are able to SSH to the worker nodes when they mention they want to use that key pair. And at the end, this is the result. We created an IAM user. We use one region. We use a couple of availability zones. We created a VPC, public subnets, private subnets, route tables, internet gateway, elastic IP, NAT gateway, and then EC2 key pair. Now the environment is ready. We have all the things that need to have been done prior to deploying any EKS clusters. In the next lessons, I will talk about how to deploy Kubernetes cluster using AWS EKS service.